The topic of this video is solving logarithmic and exponential equations. Let's take a look at a problem. Solve 6 raised to the 1 minus 6x power equals 7 raised to the x power for x. Tips 5 and 8. All right, let's talk about tip 5. These tips were mentioned in a previous video. Tip 5 says, when you have equal exponential expressions with different bases, like we have in this problem, a 6 and a 7, take the log of both sides to solve the problem. All right, so we know that we're going to take the log of both sides as part of solving this problem. That's tip 5. Tip 8 says, if there's an answer, make sure you check it. Now you might have noticed that I've written on the board here, ln9dmfd. What does that mean? This is the 6-step process we're going to use to solve a problem of this type. Let's outline all of the steps and then we will perform them one at a time. First, ln means we're going to take the natural log of both sides. Next, the 9. That means we're going to use log rule number 9. Next, distribute, then move, then factor, then divide. By doing these 6 steps, we'll have our final answer to this problem. Now, one thing I would like to mention before we begin. When you have two different numbers here, and you cannot rewrite them to both be powers of the same value, then you're going to take the natural log, you're going to take the log of both sides. But how do we know what kind of log we should take? Why did I choose to take a natural log? Well, the conventional wisdom is that you can choose any log base you'd like. You could do log base 6 of both sides, you could do log base 7 of both sides, you could do log base 10 of both sides, you could do log base e of both sides. I've chosen the natural log here because it aligns with the help resources that are available to you in your web math learning platform. All right, so with this in mind, let's go ahead and begin. We're going to take the natural log of both sides of this equation. So on the left, we'll have the natural log of 6 to the 1 minus 6x power. And on the right, we'll have natural log of 7 raised to the x power. Something else I'm going to do is I'm going to write these 6 steps off to the side. And as we do each one, we'll check it off. All right, so we've now taken the natural log of both sides. Next is log rule 9. Log rule 9 says that when your argument of your log has an exponent, like both of these, you can pick up that exponent and move it to be in front of your log as a factor. So this will give us 1 minus 6x times the natural log of just 6 equals x times the natural log of just 7. Notice that I used parentheses on the left, but not on the right. Why? Because on the left, I have 2 terms that are multiplying by my log, and on the right, I only have 1. When there's more than one term, parentheses are necessary. Now, before we continue, I'd like to remind you that a logarithm is just a missing exponent. So this right here is just a number. And this right here is also just a number. So I really want you to take a moment and imagine this is just a single value. Don't pay any attention to the fact that it's a log and that the base is e and that the argument is 6. Just think of it like it was a single object, a single value. Well, if it's a single value or a single object and it's multiplying by something with 2 terms, then I would have to use the distributive property to multiply that by both of these terms. And if I conceptualize this as just a brick, what I'm going to get is brick times 1. So I'll write it this way. 1 times this brick. Then the minus sign from the distributive property. And then the 6x will also get multiplied by this brick. Now we know that inside the brick there's a number. And that number happens to be the natural log of 6. So there, we've now done rule 9 and the distributive step. On the right, we still have x times the natural log of 7. Okay, let's do a little simplifying. Anything times 1 is itself. So therefore, this is just going to be the natural log of 6 minus 6x times the natural log of 6 equals x times the natural log of 7. We still have our bricks. It's not necessary to draw the brick for every one of these logarithms while you're solving the problem, but it helps us conceptualize that each one of those bricks simply contains a number. So treat the algebra the same way as if there was an easy, convenient number inside, like a 4 or a 6. Okay, next comes the move step. When you have an equation where multiple terms contain the variable, but some terms do not, bring all terms with the variable to one side and all terms without the variable to the other. Let's look at a simple, short, easy example of this. Let's say I had an equation that looked like this. 6 minus 6x equals 7x. Well, what you might do is to pick up this term and move it to the other side where it changes signs, and then you would write 6 equals 6x plus 7x. You could then combine like terms and continue to solve. Now, our problem, of course, is different. It's a little more complicated, but the idea is the same. No x, x, x. So let's pick up this term right here, this subtract 6x ln 6, and let's move it to the other side where it will be added instead. All right. So here's what we'll get. Natural log of 6 equals, moving this to the other side and changing the sign, positive 6x natural log of 6 plus x natural log of 7. We've now completed the move step, and we're 2/3 of our way to a solution. I'll draw my brick here, here, and here. Okay, next comes the factor step. We're trying to solve for x. Now that all of the x's are in the same side, we need to find a way to turn these two symbols into just one x symbol. And the way we can do that is with factoring. This x is multiplying by the 6 and the natural log of 6. So if we were to divide this by x, what would be left would be the 6 and the natural log of 6. This x is multiplying by the natural log of 7. So if we were to divide by x, what would be left is the natural log of 7. So what we're going to do is factor out x. And what's left? 6 natural log of 6 plus natural log of 7. On the left, I'll make no changes. And again, I still have 3 bricks. We have now completed the factor step. Only one step left, and that would be to divide. Notice that on the right, the x is multiplying by everything in the parentheses. Our job's to try to get x alone. So we need to do the opposite of multiply. And the opposite of multiply is divide. So divide both sides by everything you see in the parentheses, which is 6 times the natural log of 6 plus the natural log of 7. 6 times the natural log of 6 plus the natural log of 7. Then, on the right, this entire piece will cancel with this entire piece, both of which turning into a 1. X times 1 is x, divided by 1 is x. So on the right, I just have x. And on the left, I have the natural log of 6 over 6 times the natural log of 6 plus the natural log of 7. This is our final answer for this problem. Now, we should check it. We're going to use our calculators to check this answer. And the reason why we're using our calculators to check this answer versus other videos where we did it by hand was in other videos, the log base was a number other than 10 or e, which means we couldn't use our calculator. But in this problem, all of the logs are natural logs, and because there's a button on our calculator for that, we're actually able to check this with our calculators. So let's enter this in our calculators. We're going to enter it like this. ln is a button that looks like this, and then the argument is always in parentheses. And since we want this divided by a sum, which is two things that are being added, we have to use the division key and then put the entire denominator in parentheses. So 6 times the natural log of 6 plus the natural log of 7. If we enter all of that in our calculators, we should be able to get a decimal approximation for the value. Okay, let's do it. Here we go. So, natural log, the ln key on this calculator is in the far left column, third button down. So I'll hit 6 and then close the parentheses, division button, parenthesis, 6, natural log, 6, close parentheses, plus natural log 7, close parentheses on the argument, close parentheses on the denominator, and hit enter. We get the value of x. It's approximately 0.1411. There are other values at the end of this, but I'm rounding to 4 decimal places. Now I can check to see if that's the correct answer by plugging back into the original equation. Everywhere I see an x, I'm going to put this decimal. Now whenever you round, you're introducing a tiny amount of error into your problem, which means that the left side and the right side will not be exactly the same, but they will be really, really, really close. And as long as they are really, really, really close, that validates that we have the right answer. All right, so let's put this in our calculators. So I'm going to do 6 raised to the, I'm going to put my entire exponent in parentheses because I want the calculator to know that that entire piece is my exponent. So parenthesis 1 minus 6 parenthesis 0.1411 close parenthesis for the 0.1411 close parenthesis again for the exponent and hit enter. And we get the value 1.316 approximately. Now, on the other side, we do 7 raised to the power 0.1411 and hit enter, and we get the same rounded value, approximately 1.316. Therefore, that validates that our answer, shown here as a decimal approximation and shown here as an exact answer, these are both correct. This is the exact answer down here, and this is the approximation up here. Now this was a rather long problem, so I would like to just briefly restate the steps before we call this video closed. When the problem you're solving is of the form base raised to exponent equals base raised to exponent, and these numbers are such that you cannot rewrite each one as the power of the same other value, then the 6 steps you'll use to solve the problem are ln 9dmfd. Take the natural log of both sides, apply rule 9, distribute, move, factor, and divide.